This video is for 5.2. Okay. So, in this assignment, we need to convert from degrees to radians, radians to degrees, and then draw where radians are. And you might ask, why do we need radians? I'm glad you asked. So, a circle has 360 degrees. Any idea why we picked 360? There are 365 days in a year. So, why does 360 make more sense than 365? Well, I mean, being even helps, but that's not it. And not only split in half, but split into lots of other things. So, our number system has 10 digits. So, you can divide 10 by 2 and 5 and end up with fewer fractions than, say, if you use 7. Right? 7 doesn't divide in half, doesn't divide by anything else. But 10 would make more sense. 12 would make more sense. Because 12 is divisible by 2, 3, 4, and 6. Which means, if we switched from a base 10 system to a base 12 system, half of all of our fractions would we would have half as many fractions as we do now. Wouldn't that be nice? And there were civilizations that had base 12 systems. Why did we switch? 10 fingers. Right? They just kept trying to teach kids how to count, and only the 12-fingered kids understood, so they dropped it. So, anyway, why 360? 360 has a ton of factors. 2, 3, 4, 5, 6, 8, 10, 12, 15, 18, 20, 24, 30, 36. I could go on. And that means that when you are splitting a circle into multiple pieces, the more factors it has, the less fractions you have to deal with. So we could have done 360, but instead 365. So 1 degree is about how far the Earth travels around the sun every day. So here's the sun, here's us flying around. How big is 1 degree? It's the rotation traveled in about 1 day of the Earth's trip around the sun. So that's why we did 360. Okay, well, degrees have some shortcomings. So, for instance, the sine of 30 degrees is 1/2. The sine of 60 degrees is 0.86. And the sine of 90 degrees is 1. Okay? This is a function with inputs and outputs. So I can call these x and I can call these y. And then I graph it. So let's do 1/2. So these are my ratios and these are my degrees. Well, how far is 30 degrees? If I asked you to walk 30 degrees, you can't do it. Degrees are a rotation. They're not a distance. So we could graph it like this. Let me do, the sine of 0 is 0. So we start here, 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 here. But I just guessed where those belong. I have no ruler that tells me exactly where that goes. So maybe I'm wrong. Maybe they should be here. So there, 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 and there. And that gives me 2 different curves. Do you see the problem? I don't have an x-axis that is measurable. So we need another type of angle measurement. And it's called radians. And it actually has lots of other benefits. So we scrap degrees. We're not going to do that anymore. Instead, we're going to invent an angle measure that is linked to some length. So let's draw a circle. Right here. And let's start measuring from this line here. Okay? And we're going to rotate in that direction. That's called standard position. So if you start on the positive x-axis, we refer to that as standard position, and positive angles rotate counterclockwise. Have you ever wondered why we label the coordinates 1, 2, 3, and 4? That's the order the rotation goes through. That's why we label them in that direction. Okay? So, the problem is, if I measure the rotation, then I can't graph that on the x-axis as a function. So, instead of measuring the rotation, we are going to measure how big is the radius. Okay? Now your radius might be 6 feet, might be 2 inches, might be 7 miles, but we've decided we don't care how big the radius is because all circles are similar. Right? The equation for the circumference of a circle is the same regardless of what the radius is. So whatever the radius is, we call it 1. If it's 9 inches, we throw it out and we say 1 radian, 1 radius. And then instead of measuring the rotation, have you ever seen those tape measures that are wheels? You lay them on the ground and you walk with them? I got one of those. Those are nice because you don't have to measure straight lines. Right? You could walk in a curved path and figure out how long that curved path is. If you try to do that with a tape measure, it's going to be a nightmare. So, what you do is you stand here and you build yourself a measuring wheel where every click is 1 radius. Hi. Oh, he's the one, Tyler, that is here. He's the only one we like. So, you build your measurement wheel so that it measures radiuses. Okay? And you start walking. Not what I wanted. So you start walking, and as soon as you hear the first click, you stop. Okay? So now, this distance is equal to this distance. And we define that angle as 1 radian. So how far is a radian? A radian is the rotation needed so that the distance traveled around the circle is equal to the radius of the circle. The nice thing about this is, if I build a smaller circle, now I need a new wheel. But when I measure this distance, and then I walk that distance, that angle and this angle are the same. Which is why we don't care how big the circle is. Okay? You do have to build a different measurement device for every circle, but it turns out that doesn't really matter. So, how big is this? It's like 58.3 degrees. And it's not a very nice number. It's actually irrational. It goes on forever, never repeats. Okay? So, how many radians are in a full circle? Not 3.14, you're close. So, if I get my measurement wheel and I start walking around, how many clicks am I going to hear? If I go all the way around that circle, how many clicks is it going to make? 6 and a little bit. How did you get that? Circumference equals 2 pi r. How big is r? 1 radius. Okay, so as I go around, 1 click, 2 clicks, 3 clicks, 4, 5, 6, and a little bit. Because when I plug 1 in there, I get 2 pi, which is 6.28. Okay, which again is not a very nice number. 6.28 goes on forever, never repeats. It's twice as big as pi. Okay, so to make things easier on ourselves, we never use this number. We always use this number. So, in my circle, I say this is 0 degrees, 90, 180, 270, and 360. In radians, the full circle is 2 pi radians. But because we're really lazy, if the pi is in there, we just get rid of the radians. And we just say 2 pi and everybody understands we're talking about radians. What are the other 3 marks in the circle? Yeah, so what would go right there? 1 pi. Okay, what goes right there? Half of a pi, and we actually just do pi over 2. Keep it as a fraction. So what's this one? 1.5 pi, and mixed numbers died in middle school. So we call that 3 pi over 2. So, what if I had 135 degrees? What is that in radians? Well, if I had 16 inches, how do I convert that into feet? I multiply it by feet over inches. How many feet are in an inch, or how many inches are in a foot? So 1 foot has 12 inches, and inches cancels inches, and I get 16 feet divided by 12 is 1.25 feet. Okay, what if I had 7 feet and I wanted to convert it into inches? I multiply it by inches over feet, and there are 12 inches in 1 foot. Feet cancel feet. 6 times 12 is 84 inches. Does that make sense? That's how you can do any conversion, or actually really complicated conversions too. So in this case, 135 degrees. So I need to multiply that by pi over degrees. So I have to pick an equivalent statement. I could choose this one, or this one, or this one, but this one makes the most sense. In every 1 pi radians, there are 180 degrees. And degree cancels degrees, and I get 135 pi over 180. But if I stick that in my calculator, I'm going to get some terrible decimal that doesn't simplify. Okay? So instead, I'm just going to simplify this and throw my stylus on the ground. So in my calculator, 135 divided by 180, the fraction form is 3/4 pi, 3 pi over 4. Okay? What if I go the other direction? What if I have 5 pi over 4, and I want to convert that into degrees? Well, I need degrees on top and pi on bottom. How many degrees are in a pi? 180. pi cancels pi, and I get 5 times 180 over 4. So 5 times 180 over 4. 225. Does that make sense? So as long as you can remember this, converting from degrees to radians or radians to degrees is pretty simple. The one thing you do have to remember is we try to make our radians in fractions of pi. So never plug the whole thing in your calculator. Just simplify the rational portion and then stick pi on the end of it. Okay? Do you need to see any more of those? So, let's do this. Okay. So, for this one, 270 degrees, we want to convert it into radians. So we put pi over degrees. In every 1 pi, there are 180 degrees. Degrees cancel degrees. 270 divided by 180 simplifies to 3 over 2. So 3 pi over 2 is the answer. Okay, if I want to do the other type. Oh, are you serious? Has anybody gone into this yet? Oh, that is... Hold on a second. They're being really dumb. It is rounded to the nearest hundredth. Okay. Okay, that's easy. Okay. Okay, well, yeah, we're talking about that here in a second. So in this case, 3 pi over 14. I want to convert that into degrees. So I put pi on bottom so they'll cancel and degrees on top. And there are 180 degrees in every 1 pi. Pi cancels pi. And 3. So 3 times 180 divided by 14. Oh, it wants a decimal answer, so 38.57 degrees. Now, I told you we like to keep pi in our answer, and we really do, but anyway, what if it said 3.21 radians? There's no pi in there. It's in there, but we usually don't put it in. So when you run into one of these problems, just know there are 180 degrees in every 1 pi radians. Radians cancel radians. And in this case, because I already have a decimal, just plug the whole thing in your calculator. 3.21 times 180 divided by pi. All right, but whenever possible, don't put pi in your answer. So if there's already a pi in there, that makes your life easier. But if it's not there, then you're just going to have to divide whatever decimal they give you by pi. Okay, so somebody had a good question. Where is this number here? Well, let's think of it as a fraction first. So from here to here is a full pi. So what quadrant would 3/4 of a pi land in? 2. Not 3/4 of the circle, 3/4 of pi, which means 3/4 of the top half. It would be right in the middle of quadrant 2. So this would be 1/4, 2/4, 3/4. Well, right here, we stated that those are equal. Where is 135? 135 is halfway between 90 and 180. Okay, what about this angle? Where is it going to land? So it's a little bit bigger than a full pi. So the top half is 4/4, and one more would be 5/4. We're in quadrant 3. Okay. No, yeah, it's really, if you think of it in fraction form, it's really not that bad. Okay, what about 3 pi over 8? What quadrant is that going to be in? One. So this is 8 pi over 8, right? And where is the third piece of that? It's not quite half, it's a little bit below half, so it would be like right there. Does everybody undersee? Does everybody understand? Okay. What about 7 pi over 4? Where does that land? Four. Okay. How far is it to here? 1, also known as 4/4. How far is it to here? 8/4. So where is 7 compared to 4 and 8? Closer to 8. So this angle here is 7 pi over 4. Okay, now these do get a little bit tricky. Come on. That took a lot longer than I expected. Okay, what about 7 pi over 3? Where is that going to land? One. So how far to here? 3. How far to there? 6. How far to there? 9. So compared to 9/3 and 6/3, where is 7? Quadrant 1. All right. Let's mix it up a little bit. What about negative 6 pi over 5? Where is that going to land? Two. Okay, so we're going backwards. How far to there? 5. One more would be 6. Okay. All right. You could do the same with degrees. Where is 410 degrees? That'd be all the way around. And how much more? 50 more. So, in the coordinate plane, using standard position, those angles are exactly equivalent unless you're a snowboarder. Right? Of course, if you pull a 50 degree on a snowboard, what's that called? A crash. Yeah, I don't think you can pull a 50 degree and stay upright. If you're a snowboarder, a 180 and a 540 are different, right? One's more difficult. But mathematically, 180 degrees and 540 degrees land in exactly the same position, and we call those coterminal. So these two angles are coterminal. I can't spell. Okay. So if I asked you, what is an angle that is coterminal to 120? How would you find that? Times what by any number? Not 120. You add 360 or any multiple of 360. So 120 is right here, and I could go around this way or even subtract 360, and all those angles land in the same place. In degrees, it's really easy. Turns out in radians, it's actually a little bit easier. So let's look at 8 pi over 5. Where is 8 pi over 5? Quadrant 5? It's going to be right there. Right? It's more than 1 and smaller than 2, but it's closer to 2 than it is to 1. Okay? Can you tell me another angle that lands in the same place? Well, I just need to add a full circle to it. What is a full circle in fifths? Right? So what other angle lands in that place? 18 pi over 5 or 28 pi over 5 or 280 pi over 500. I could even subtract and get negative 2 pi over 5. All of those angles are coterminal. They all land in exactly the same place. Man, I've got a problem. All right, so number 3 says sketch the angle in standard position. So you just need to figure out where does it land. Number 4 gives you an angle and says find another angle that's coterminal, but it gives you a qualifier. How many answers are there to coterminal angles? An infinite number. But of all the answers out there, it tells you which one to pick. So how am I going to turn this into a coterminal angle that fits inside that window? How will I make it positive? Well, what is a full circle in this case? 20/10. So I'm going to do 20 pi over 10. Do I want to add or subtract? If I subtract, I'm going to get negative 23 pi over 10. Is that what I want? No. Is that number between 0 and 2? No. So if I add, I get 17 pi over 10. Is this number between 0 and 2? Yes. Okay. For the degrees, how do I turn this into a number inside there? Subtract it. So pull up my calculator. 990 minus 360. I get 630. Am I done? No, why not? It doesn't fit in the window. So what do? Subtract 360 again. And I get 270. Is that what I wanted? Yes, that fits in the window. Okay, and the last problem. A circle has a radius of 7. Find the radian measure of the central angle if the arc length is 6. So, I have a radius of 7. Draw my circle, and I travel around that circle 6 inches. How big is this angle? Well, how much of the radius did I use? I used 6/7 of a radius. Right? My radius is 7 inches, and I only used 6 inches. So I used 6/7 radiuses. How far is it from here to here in inches? Not 14. It's pi radians, right? So how far is it from here to here? 7 pi inches. So how do we figure out the angle? So it's kind of difficult. Okay, hold on a second. What if we did this? Find the rate. Okay, I just wanted to make sure that it wasn't in degrees. How would we figure that out in degrees? If this is 7 and this is 6, how big is the entire circle? It's 14 pi, right? And we only used 1/6 of that, or 6 out of 14 pi, and that will give me a percentage. I think I'm making this more complicated than I need to. So 6 divided by 14 pi. Oh, shoot. Oh! I broke it. Okay. Oh, shoot. Got to use the same set of parentheses. Okay. So that's saying I used 13% of the circle. So what is 13% of 360 would be 49 degrees. Okay. How would we do that in radians? So I draw the same circle. My radius is 7. So how big is the entire circle? 14 pi. Right? How much of the circle did I actually use? 6 out of 14 pi. And I'm done. Because in radians, the unit of the radius is the same as the unit of the circumference. So I go back here, and the answer is 0.1, what does it say, round as nearest hundredth, nearest tenth? So 0.2. See if I'm right. Maybe I pushed enter. Maybe I can't push enter. Oh, incorrect. Uh-oh. What'd I do wrong? So did I just round it wrong? Is it really that easy? Oh yeah, I thought it was 0.16. Sorry. So round that to the nearest tenth, 0.1. That scared me. I thought, wait a minute, I did it wrong. So the answer here is just 0.1, not 2.1. 0.1. What did I do wrong? Radius of 7 arc length of 6. Oh, 6/7. I didn't need the pi. So anyway, that's where we're headed. The formula is this. S is the arc length and R is the radian, so I plugged pi in. I didn't need pi. So to find the angle, all you have to do is take the arc length and divide it by the radius. That's your answer. Sorry, I made it more complicated. And then round to the nearest tenth. Okay? Get to work.